Hello everyone, welcome to this channel. Today we'll solve this yesterday Job-A-Thon. So over here we have three questions. I'll go one by one. So first question is police station. So here, okay, I'll explain this problem with example directly. So what we have given is we have given an array and we have to maximize this particular value a minus. We have to choose some number from array xi. We have to take absolute value of this plus some other number x of j. This one we have to maximize this absolute value. So we have to choose two numbers from this particular array such that this particular value becomes max. So over here, if you see what we can choose, let's say if we choose first number is 10, second number is 17, then this value would be 10 minus 2, which is 8, and next 17 minus 2, which is 15, which comes out to be 23. In this case, this value comes out to be maximum. If you choose any other number, you will get somewhat lesser than or equal to this number. So if you see this particular expression, what it says, you have to choose two distinct number because this is xi and this is xj, such that this number is this particular formula comes out to be max value. So and there is one constraint as well. All these numbers in this array is positive only. So let's see how this difference is. So basically this is absolute difference, right? So if you draw the number line over here, there are numbers over here, here, right? Some places there would be a value given as a. Let's say a is present over here. Now you have to choose two such numbers so that the gap from a is maximum, because these are the plus over here. If this value is max and this value is max, then overall value would be maximum. So from here, which number you will choose? The numbers which are at max distance. What are those possibilities? For example, that number could be at left side, that number could be at right side as well, right? So for example, here in this case, let's say I might choose this particular number, first number over here, second number over here, which comes out to be the max difference. Either other options would be, if you choose these two numbers, this comes out to be maximum. So for example, let's say if we have a number line over here, a is here and numbers are like this, and these are the last two numbers. So if you choose these two numbers, then obviously you will get the maximum because there is no number to the left of it, right? So there are only three cases possible. So if we have a over here, then what are the three cases we have? Let's say last two numbers at the left side is these two and last two numbers at the right side is these two. So here if you want to find the maximum value of that absolute difference, then either it will be these two number or these two number or last number from here and last number from here. So we have only three cases. Fine. So let me quickly show you the solution. Over here what I did is we just need to find the two minimum number and two maximum number. For that I just use priority queue, or you can use variables. Anyway, once you find these two numbers, two max number or two min number, and then there are only three cases, right? I showed you. So just calculate with the help of that and you will get it. Let's think about the time and space complexity over here. So here what we are doing is just we need to find the two min and two max number from the array, which we can do in linear time, and after finding this you need to calculate this particular function. Only three cases are possible, which is a constant operation. So overall time and space complexity comes out to be O of n and O of n. Fine. Let's move on to the next problem. So over here, this problem is again I'll explain this problem with example. So over here, so what we have given is we have given an array of size 3 into n. There is a number n and this array size is 3 into n. So what we need to do is we have to remove n numbers from this array. Fine. And then whatever numbers are remaining, partition the array in two parts and then find the sum of these two parts. Let's say first part sum is s1, second part sum is s2. So we have to basically maximize this particular value. Fine. Let me iterate over here. What will happen is here n equals to 2, so total size of this array comes out to be 6 because 3 into n. And now we have to remove two numbers from this array in such a way that remaining two partitions sum value, if you calculate this thing, has to be max. So let's see, 1 3 5 2 1 and 1. So what we can do is, let's say I removed one number from here. Let's say 1 I removed, and then one more number we have to remove. Let's say 2 I removed. Then what will happen is, there are two partitions, and now total size of array is 3 into n. So we remove n number from this array. So remaining how many numbers are there? 2n numbers. So we have to partition these two numbers in two parts. First part has to be n number, second part has to be n number, and sum of these number has to be s1 and this one s2. Fine. So over here, now first two numbers are 3 5, second two numbers are 1 1. So what is the sum of this? Which comes out to be 8. This sum comes out to be 2. So this one we consider as s1, this one we consider as s2. So difference of this will be comes out to be 6. So we have to choose such a way these n numbers which we need to remove in such a way that the difference of these s1 and s2 comes out to be maximum. Fine. And these two groups has to be the same number of elements, like n number from here and number from here as well. So if you see here, to maximize this particular expression s1 minus s2, what we have to be, if you see here, this number has to be, we need to maximize this. Then obviously we have to maximize this s1 and minimize this s2. Fine. The first group has to be the maximum sum, second group has to be the minimum sum. Fine. And we know that the number of element in both the groups has to be n only. Fine. So what we can do is simply choose numbers, means partition this given array in two parts and remove few numbers from them such that the size of both the group comes out to be n. For example, here if you take the same example 1 3 5 2 1 1, there are multiple ways to partition it. Let's say we can partition from here only, right? Because at least two number has to be there. Then if you partition from here, then first group has to be 2 element, second group becomes the 4 element. Now somehow we have to remove two numbers from here. Let's say, because we will remove maximum number because we want s2 to be minimum. So let's say we remove 5 and 2, then first sum will be what? 4, second will be 2. So in this case difference comes out to be 2. Similarly, other possibility will be what? 1 3 5 2 1 1. We may partition from here, and now 3 elements will be here and 3 elements will be here. Now what we need to do is, we have to remove one number from first group and one number from second group. Which number will remove? From here we need to maximize, so we remove 1. From here we need to minimize, so we'll remove 2. So here comes out to be what? 8, and here comes out to be 2. Then difference comes out to be 6. Similarly, there would be one more possibility. Let's say 1 3 5 2 1 1. Let's say we partition over here, right? Then what we need to do, we have to remove two numbers from here. What are those? We have to remove two minimum numbers. Let's say 1 and 2 will be removed. Now here comes out to be 8 and here comes out to be 2. Then difference is again comes out to be 6. Do you have any other partition? No, because at least two element has to be there. Fine. So what we can do is, the basic solution would be, just try for all the partitions we have, and then in each partition try to remove the elements. Like if you are in the first partition number of elements are more, then try to remove the minimum numbers. And if in right partition number of elements are more than n, then we have to remove the maximum numbers. So how many numbers we remove, how to choose the maximum number, the best data structure would be the heap. Fine. So what we can do is, we can create a max heap as well as min heap. So after creating max heap and min heap, what we can do is, we know that if let's say in the first group we have a total n plus 2 elements, so we know that we have to remove top 2. It means this has to be the what? Min heap, and from this min heap we have to remove the top 2 element. After removal, whatever the sum of that heap, that would be my s1, right? So we have to try for all the partition and we have to choose the min and max heap accordingly, and then find out the difference. Fine. Let me show you the solution. first. So here what I did is I created the max and min heap, and every time this heap size would be n, because we only consider for the n elements. If there are more elements, let's say for the S1 partitions, right? If there are n plus 1 element, do we consider it? No, because if first partition has to be maximum, then the minimum element has to be removed. So from min element we'll remove the topmost element. So similarly for the S2 as well. So what I'm doing is I have created this, and then I have created this two array as well, which is called top n sum and bottom n sum. This will represent the S1, this will represent the S2, and similarly we choose the number. Means it's just basically partition the array. What are the sum from the first part, what is the sum from the last part, right? So here I'm just updating this heap as well as this particular array. Here I'm updating the second part, and now here comes the where we are going to partition and what would be the difference. So basically we have to we have total, this would be equal, we have total n plus 1 options, right, where we can partition, and based on that we will find the difference of this, and whichever comes out to be maximum we'll update the maximum. So let me just tell one more thing over here. So what is happening is, so let's say this is the total size of array, which is of 3n. So from this particular value, let's say this one is n, so this is the first partition, right? And now from here, let's say there are n again, and this is n again. So what are the options we have? We can start partition from here, then here, and blah 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 till here. So total how many options we have? N plus 1. And in each partition, what we need to know? We need to know what is the maximum sum I'm getting from here to here in the first partition. What is the minimum sum I'm getting in the second partition? That's what we need. So for that I use this top n sum and bottom n sum. That will represent basically the topmost n elements value. For example, in this case we'll take top n element, means what is the maximum sum of n element, and in this case what is the minimum sum of n element, right? And then subtract it. Road blockage. So here in this problem basically we have given a tree where nodes represent the city and the edges represent the bidirectional roads. So what we need to do is I'll explain with the examples only. If you look at here, this particular tree, so in this tree we have a path length. For example, 0 to 1 its distance is 1, from 0 to 3 its distance is 2, similarly for 4 is 2, for 2 is 1. Now the question says that we have few queries are given. Queries is basically a particular age. So what we need to do is we have to remove that age from this particular tree, and then we need to find out what is the maximum distance of any particular node, and we need to return that particular distance. In this case, for first query, if you take 0 to 1, it means that this particular age will be removed, and now if this particular age will be removed, there is no path to reach 3 or 4 at all. So there is only one path from 0 to 2, and what is the distance up to 1? So what is the maximum distance? 1. Let's say another case, 1 to 4. If you remove this particular age, then what will happen is there is a one path from 0 to 1, another path from 0 to 3, another path from 0 to 2. Which one is the maximum? 0 to 3. What is that distance? 2 only. So we have to return 1 and 2. First query returns 1, second query returns 2. Okay, let me clear out over here. Okay, so basically whatever tree we have, let's say we consider always 0 will be the source, and then maybe it's not necessary to be binary, right? Something like this, and there will be 4, there will be 5, there will be 6, something like that, and there will be 7. So once there is a blockage, once there is some of the particular age is removed, for example if this particular age is removed, then there is no path to reach from 1 to any of these node. So only path, in this case what would be there? There is a path from 0 to 1 to 5 to 2, 6 and 3. What is the maximum? To here or here? What is the answer? Right. So similarly if you can remove any age, and then we have to return the uh, maximum distance. So what we can do here is, one simple solution would be, once the particular edge is removed, then run the DFS from that particular node, from source. Okay, and now if you run the DFS or BFS, any particular algorithm, then it will give you what is the maximum distance of any particular node. Fine. But what is the problem in this approach? If you see the time complexity, if you do like this, for each query, right, let's say if you have q queries, okay, then what we are doing is, for each query we have to apply the BFS or DFS, which will take O of n time, and then time complexity would be q of n. But if you look at in the question, the range of n is 10 power 9, n and q both. So if you go for this solution, it will be 10 power 10, which is not 1 second solution. So let's think of some optimization. So if you look at here, for each query, we somehow need to solve it in lesser time than n, right? So obviously we won't be able to run the DFS or BFS multiple times. Fine. And another observation you can see is, once a particular edge is removed, what does this mean? If this particular edge is removed, it means that the subtree rooted at this node is completely removed. Fine. If this particular subtree is removed, then remaining tree only we need to consider. But can we run the DFS or BFS again? No, because of the time constraint. Fine. So somehow we need to run the traversal only once, and we need to save this thing in such a way that somehow we can remove any of the subtree. Right? Just think about it. Let's say we run the okay, just think about it. Let's say if we run this DFS traversal and we try to remove some particular subtree, can we do that, or we have any problem in there? Let's say, what is the DFS traversal of this? So firstly it will traverse 0, and then it will go to its child. Let's say it go to 1, then maybe it go to 4, then let's say it goes to 7, and then it will come back, then it will go to 5, then it will go to 2, then 6, then 3. So this will be the DFS order for this particular tree. This is one of the DFS order. So fine. Now if you see this particular edge is removed, then what will happen is, we have to remove subtree rooted at 4. So in this particular path, if you see 4 over here, but what are the nodes we need to remove? In this case we have to remove 4 and 7. But how many nodes it will be there? Do we know from this particular path? No, right? Because there might be some other node. Let's say there is a node called 8, right? So 8 will also be there in over here. But how we know that how many nodes are there in that particular subtree, and how we need to remove it? So one simple solution is, in DFS traversal only, what we can do is, we can add the particular node 2 times. For example, here at the beginning also, at the end also. Let's say once this particular subtree is over, add 4 again. Similarly for other nodes as well. Let me just quickly write the final DFS after this particular modification. So here what will be there? So firstly we will start with 0, then it will go to 1, then it will go to 4, then it will go to 7, and then again it will go to 8. So here just come back over here. So once 7 is there, so 7's all the left subtree, right subtree, and everything is completed, then again 7 will be added. Now we reach to 8, and 8's subtree is over, then add 8 again. Then now 4, all the subtree rooted at 4 is over, right? Then 4 will be added again. Similarly we'll come back 1, then I'll go to 5, all subtree will be over, then again come back to 1, all the subtree rooted at 1 is over, so 1 will be added again, and again come back to 0, then go to the other branch which will be 2, then 6 is over, now 2 is over, then go to 3, now everything is over, 0 is also over. So this will be the particular path or the DFS traversal. If you go that if you try that particular modification, that key, we have to add that particular node 2 times, like at the beginning when we visit that particular node first time, and when we visit that particular node last time. So what is the advantage of doing this? This way, if someone says that remove that this particular edge from 1 to 4, then we know that subtree rooted at 4 we need to remove. Fine. So we know that what are the subtree we have to remove? This one only. Fine. So if you remove this, then we have to just find what is the maximum, distance over here and what is the maximum distance over here. Fine. And maximum distance we can calculate while we traversing. And to do this in O of 1, instead of traversing this particular list again, we can use something called prefix over here, prefix max over here, prefix max over here, and here we'll use the suffix max. So what will be our solution is run the DFS and create a list something like this, and then for any particular node, if there is a query comes from 1 to 2, let's remove this edge. So see that which particular node is tree. It's like a tree is something like 1 to 2 or something like 2 to 1. So whichever at the lower level, so along with while doing the traversal we should also save the level as well. So whichever present at the lower level, the tree rooted at that has to be removed. So what we can do is go to this particular list and remove that particular subtree. Removing, I mean just finding, let's say this particular subtree rooted at 4 we need to remove, then what would be my answer in this case? So my answer would be what is the prefix sum over here and what is the suffix sum over here, and max of these two, max of these two will be our answer. And if you know the index over here, so prefix sum would be called at here and suffix sum will be called at here. Fine. Let me quickly show you the solution. Okay, so here what I did is I'll start from DFS. So what I'm doing over here in the DFS, before that one more thing I wanted to say. These are the few structures I took. One is the distance. So this will be something like this. So here these are the matrix of 4 columns. In each columns what I am storing is, first column value is the city, second value is the distance from the origin from 0, and third is the prefix sum, and fourth is the suffix sum. Fine. And there I use a map. This map is basically saying the if you ask for a particular node, let's say for city 2, then it will tell you what is the starting and ending index in this particular distance matrix, so that once we know the starting and ending index, and then we can remove that subtree and find the prefix and suffix sum and maximize this and get the final answer. Fine. So I'll show you what I'm doing in DFS. So in DFS, the normal traversal, if node is visited we have to return, otherwise mark it visited. And now here I'm updating two things. Firstly, I'll updating the distance. So distance of 0 and 1 says that 0 is saying what is the start, right? So we have to save in that particular list that where that node start, right? The start of this node, and then label is basically the distance from 0, and similarly at the end we have to update the we have to add the one city 2 times, right? As I told you in the over there. So first time we add when we visit the node first time, and once we explore all its children, then we have to add it again. So over here I have added, and now in the map basically we are adding the starting and ending index. So here firstly we add the starting index, and once we know the ending index we'll add the ending index as well, right? This index is the index in this particular matrix, right? Means the row number. Fine. After DFS is done, then what I'm doing is, so here basically just the graph creation till here, and then calling the DFS, and after that once we have the DFS, then updating the prefix sum and the suffix sum over here, right? So once we update this prefix sum and suffix sum, then it's very simple. For each query we'll see which particular node is at the lower level. So in this case D1 is the smaller value and D0 is the larger value, means D0 is the lower level. So for that D0 I will find the prefix sum, I find its index, and -1 I'll call the prefix, and plus 1 I'll call the suffix sum. Out of them, whatever will be the maximum, that will be the result. Similarly, in other case, it will be the D1. I'll do the same thing over here. Fine. Let's think about time and space complexity over here. So time complexity, if you see, we are doing normal DFS traversal, right? Which will take O of n time. And after that, we are updating few of the structures, and then these are also a linear time complexity, and just finding over here. So time complexity would be O of n. And think about the space complexity. So what extra thing we are doing is we are creating a graph, and then we are creating a map which is of n size, and this which will be a 4 into 2n, which will be of n only. So overall space complexity would be of n. Thanks for watching. Hope you like it, and if there is any query or suggestion, please enter in the comment section.